Hello everyone! In this video I'll talk about ultraviolet catastrophe, blackbody radiation, Rayleigh Jeans Law, and Planck's law. Let's go ahead and get started. So, after Maxwell's theory and Hertz experiment, scientists strongly embraced the idea that light is a wave, specifically an electromagnetic wave. Hertz work confirmed that radio waves, which are just long wavelengths electromagnetic waves, behaved exactly like a light in terms of reflection, refraction, interference, and diffraction. This was seen as a solid proof that all light was part of the electromagnetic spectrum. For a while, this seemed to settle the debate between the wave and particle theory of light. The older particle, the corpuscular theory of Newton, fell out of favor. Maxwell's equation described light beautifully as continuous oscillating field traveling through the space, needing no medium and no obeying the math of waves. Then, in 1800s, physicists tried to explain the spectrum of light emitted by a perfect blackbody. The blackbody is actually the idealized object that absorbs and emits all frequency of radiation. So here, as you see, this is the light spectrum shown on here. So and this equation is called Rayleigh Jeans Law. So Rayleigh Law was the classical physics prediction for the spectrum of blackbody radiation, just like you see here on the screen. As you see, it worked very well at the long wavelengths and a low frequency from here until right here, correctly describing how intensity increases with the temperature. But when scientists use it to predict the intensity at a shorter wavelengths or higher frequency, especially on this ultraviolet region, it said that intensity should increase without the limit. It went to infinity as wavelengths got shorter, which is of course wrong. According to this equation, these wavelengths, all the line, should go infinitely high. But as you see, the actual experiment was not the way how they predicted. The experiment showed that the real blackbodies actually peaked at certain wavelengths, which shifted with temperature, and then the intensity fell off sharply, as you see here, at shorter wavelengths. The failure at shorter wavelengths was called the ultraviolet catastrophe. So again, what exactly is ultraviolet catastrophe? Ultraviolet catastrophe is the deviation of this experimental blackbody spectrum from the classical Rayleigh Jeans prediction at specifically higher frequency. So the classical physics breaks down. And then something happened. Great physicist Max Planck realized the failure came from the classical physics, which is assuming that the energy of the oscillator could vary continuously and have any values. Instead, he proposed that energy could only be emitted. This energy only can be emitted or absorbed in a discrete amount, specific quanta. Specifically, he said that the energy of this oscillator was quantized in units proportional to frequency. And there, he actually proposed his very famous equation, which is E is equal to h nu, where E is the energy, h is the Planck constant, and mu is the frequency. So, by using this idea of quantized energy, Planck derived a new formula for the blackbody spectrum, which you see here, right on the bottom of the change wasn't just a mathematical fix, it introduced the revolutionary idea that the energy is quantized, laying the foundation of quantum theory.